earth is my home. I promise to keep it healthy and beautiful. I will love the land, the air, the water, and all living creatures. I will be a defender of my planet, united with friends. I will save the earth.
The Metropolitan Water Reclamation District of Greater Chicago is one of the largest and most efficient wastewater treatment agencies in the world. The district treats and disposes of all the wastewater for more than 5.4 million residents of the city of Chicago and 124 adjacent communities, as well as an industrial and commercial load equivalent to another 4.5 million people. The Northside Treatment Plant mimics the purification processes that occur naturally in rivers and streams, condensing what would take 1 or 2 weeks to just under 8 hours. Sewers from 125 municipalities, including homes, factories, and businesses, empty into 7 wastewater treatment plants in Cook County. The 7 wastewater treatment plants are the Northside or O'Brien plant in Skokie, Illinois, the Curie plant in Des Plaines, Illinois, the John E. Egan plant in Schaumburg, Illinois, the Hanover Park plant in Hanover Park, Illinois, the Lamont plant, which is the smallest plant in Lamont, Illinois, the Calumet plant located next to Lake Calumet on the far south side of Chicago, and finally the Stickney plant in Stickney, Illinois, the largest wastewater treatment plant in the world. The Northside Water Reclamation Plant is the oldest of the 7 wastewater treatment facilities within the metropolitan Chicago area. The main portion of the plant began operation in 1928 and was a model for modern sewage treatment technology as we know it today. The plant serves over 1.3 million people, residing in a 141 square mile drainage area, which includes the city of Chicago north of Fullerton Avenue and the northern suburbs to the Lake County border. The process of treating water goes through the following stages. First, the wastewater goes through a collection system where water enters the plant through the sewer system. Then, the wastewater goes through a preliminary treatment where waste is removed from the water. The wastewater then goes through a primary treatment where solids settle to the bottom while fats and oils settle to the top and are disposed of. Following that, the wastewater goes through a secondary treatment where aeration tanks pump air into the water to clean it. The treated water then goes through the last stage, or the final settling, where solids sink to the bottom and are sent to concentration tanks while treated effluent is discharged into the river and canals.
My name is Commissioner Frank Avila, and we're at the Terrence O'Brien plant, which used to be called the Northside plant. And I'm here with our tour guide, Tom Phillips. And Tom Phillips is the person that gives the tours here at the Terrence O'Brien plant. And Tom, how long have you worked at the district?
I've been at the district now for about 2.5 years.
And how long have you been a TPO?
2.5 years, the whole time.
And what is TPO?
I'm a treatment plant operator 1. I started as a vacation relief, and now I'm just a treatment plant operator 1, but I still give the tours here at the Terrence O'Brien Water Reclamation Plant.
And Tom is one of the top tour person here at the Metropolitan Water Reclamation District of Greater Chicago. He gives all the tours here on the north side, and we're going to go through a tour of the Northside plant, or the Terrence O'Brien plant. Okay then, Tom, let's come into your room where the people will come in and review what you're going to say.
Thank you, Frank. If this was an actual tour, I'd introduce myself as I did. And as you can see here, that we have hard hats for all the members of the tour, usually colleges and grade schools. And it's a working plant. We all have to wear hard hats. And we all have to wear hard hats as we do the tour, not so much in this building right now, but they would grab a hat, and then I would step over here, and after everybody sat down, I would explain, what we do over here at the Northside plant, the Terrence O'Brien plant. It's 97 acres at this particular plant. We serve about 1.3 million people here at this particular plant. That's a combination storm sewer and the sanitary sewer combination. So our actual flows change quite dramatically during rain events. We cover about 141 square miles over our covered area, and our borders are Fullerton Avenue on the north. We have the Lake Michigan on the east, and the Des Plaines River on the west, and Lake Cook Road on the north. That's a generalized area of the area that we cover here.
Yes, Tom, and Tom mentioned the area that we cover, and he mentioned the amount of population that we cover. The population is 1.3 million people, right, Tom?
Correct.
And what the plant does is that we treat wastewater, right?
Wastewater and stormwater.
Wastewater, stormwater. Now, the definition of wastewater now is that when we say wastewater, a lot of people don't know wastewater. What's wastewater? Well, I call it the two peas in the pot. We treat the two P's. We treat poop and pee that comes into the plant here of 1.3 million people. Also, we treat the wastewater that comes in when it rains and the water comes into our system. And then we treat all the waste from industry and manufacturing. That is wastewater.
Correct.
And so we are the expert in treating poop and pee. We are the expert in treating poop and pee. Here's Tom.
That is correct. We're very, very efficient at what we do. And as a generalized idea, before I start a video or ask for questions, I'd explain this right here is the raw influent. This is pretty much what the water looks like. It has everything in it. What he said, the two peas in the pot, and it also has grit from the streets, glass, crushed rock, everything that's in the curbs, all comes into our raw sample. This is what comes into the head of the plant. Like I said, I mentioned the raw water. This is where it all comes in. And now when we remove the sand, the grit, the fats, and the oils in our first step of our treatment process, we're left with a lot of organic solids, a lot of microorganisms, and we introduce dissolved oxygen, a lot of air into the treatment process, and it makes the microorganisms more active, and they do what we want them to do, is remove the organic solids, and they also get the organic solids to settle out. This will settle out, and that would, at the bottom of it, would be called sludge. We call it sludge, and it's about a little bit more than half we save, and then we send a certain percentage of it to waste. We remove the settled material, and this is our final effluent. Now that's a very, very short version of what we do here, but that at 9:30 this morning is our final effluent, and compared to this, which is the raw. And it's a very, very efficient process.
Yes, and Tom mentioned about dissolved oxygen, because since we're working with liquid, with wastewater, is that the oxygen is dissolved oxygen in wastewater, whereas a human being, we need oxygen to live, to breathe, where they need dissolved oxygen to survive in wastewater. And that's why they introduced dissolved oxygen, and that's why that's one of the key portion of keeping our wastewater treated by using inputting more dissolved oxygen into the system.
Yes, the organic microorganisms could not survive without proper DO. So part of my job as a treatment plant operator is to make sure the DO stay consistent and considerably higher than what they do when they first come in the plant.
And we're going to go through the various process of how we achieve this from the raw sewage to the effluent effluents, and we're going to walk around the plant explaining how we achieve this.
Okay, now this section of the tour, I would show a video, and it's a generalized of how the district got started. And I also would have a question and answer session, but that is not going to be the case right now. So I'll just show the video of the water reclamation. Our goal is clear.
The Metropolitan Water Reclamation District of Greater Chicago. For more than 100 years, we have been working to clean and preserve our water and natural resources. By developing technologies to control flooding and adopting policies that will protect the water environment, we make our communities a better place to live, work, and raise our families. The Metropolitan Water Reclamation District of Greater Chicago serves a population of 5.1 million people in the city of Chicago and 124 suburban communities. As an autonomous government agency, separate from the City of Chicago and Cook County governments, we treat an average of 1.4 billion gallons of wastewater every day, 365 days a year. The staff of 2,100 men and women, under the direction of a 9-member Board of Commissioners elected by the voters of Cook County, includes engineers, scientists, operators, and various labor groups, all dedicated to continuous improvements in the quality of our water and environment.
Once again, this is a video that we show to all the tour groups. It covers the water reclamation of all Greater Chicago, not just the north side. It's very a lot of good information in there about how we started, where we came from, and where we're going in the future.
And the district is consists of 7 wastewater plants. 3 are considered the largest in North America, and 1 is considered the largest in the world, which is Stickney Treatment Plant.
When a tour group comes in, before they leave, I ask them to take some of the handouts we have over here at the Water Reclamation District. This is an overview over here of how any treatment plant will work, not just ours. And this is for the grade schools. Sewer Science, very nice booklet. And then, you know, it's a toilet, not a trash can. And then a new problem that we're having, and I'm hearing a lot about, is drug-free drains. That could be a serious problem in the future, and it's becoming a problem right now.
Yes, as Tom mentioned, the drug-free drain is a problem, and they're always asking me, how do we keep this out of the system? And my answer is stay healthy, don't take it. Eat right, exercise, and if you're healthy, you don't have to take any prescription drugs. I think that's the only way to keep it out of the drain.
Okay, we're good.
Looking east over the O'Brien treatment plant, you can see the original 8 primary tanks, and then to the immediate left, you could see the concentration tanks where we settle out the solids and send the waste to the Stickney plant via a pipeline of 18 miles. And then in the further distant future or horizon, you can see the grit building where we remove the grits and the fine screens. And off even more, a little bit to the left, is the original service building. It was built in 1927. That's where the trades primarily do their work. And then the tanks that are to our left and down are aeration tank battery A and aeration tank battery B. And the aeration tanks is where we do most of the biological process, and that's where we remove most of the organic solids. We accomplish in 4 hours what takes the fields and the streams 4 to 5 weeks. This is looking north from the O'Brien treatment plant. We're looking at C aeration tank. This is a better view. You can actually see what's going on here. We're injecting air into these tanks, which is helping the biological process mix with the organic material we call food or sludge, and it's helping remove the organics, and this is the actual treatment process to where it would lead to the next stage of our treatment. Adding air to raw sewage at this point raises the DO, and the dissolved oxygen is very essential to treatment process at this particular plant. In west, you'll notice that the primary tanks are around here. These are the newer style primary tanks. This is looking west. We have a total of 16 primary tanks. These 8 are newer than the first 8 looking east.
The Pump and Blower Building is the first stop on the tour of the North Side Treatment Plant. The Pump and Blower Building contains the main sewage pumps that lift sewage from the incoming sewers to an elevation that allows the sewage to flow to the rest of the plant by using the force of gravity, or gravity flow. This is also the building that contains the blowers that supply the compressed air to the aeration tanks. The coarse screen removes large materials such as timber, plastic, and garbage from the incoming sewage.
This is the first part of our walking tour. This is the pump and blower building. This is where the water comes in on 3 different channels from the city. And it comes, this is the first part of the tour. This is where the water comes in and is introduced to a coarse screen where bigger material is removed from the water. Looking at here is the coarse screen. We're removing the larger objects of the wastewater. That rake that is going down there very slowly is going to fall below that water line, and it's going to remove objects that are 3 inches or larger, and that's why it is the coarse screen. In another building we have a fine screen, but in this particular part of treatment, this is where we're removing the larger pieces of wood, rocks, and larger items. And we're at low flow right now, meaning we're only going to use 1 screen. But if we were at high flow, all these particular rakes would be on and we'd be removing that debris.
So Tom, this is the first step of the treatment process where the wastewater, as I mentioned, is a combination of the 2 P's, poop and pee, all the rain, all that rain, when it hits the ground, it goes into the sewer, it comes in here, and all your industrial waste. This is wastewater.
That is correct, Frank, and like I said, this is the very, very first process as it enters the building from the city. And from this point on, we're going to go into another section of the building. We're going to raise this water level up 40 or 50 feet using sewer pumps, 1 of 6. And then the whole treatment process is going to be gravity fed from that point forward. Very interesting step. Would you be the next phase?
Very interesting, Tom. And this room is called the...
This is the pump and blower building where we have our pumps and our air compressors. We just simply call them blowers. Finally does come up and complete its cycle, it'll reach the top of the platform here and deposit any solids, any rocks, pieces of wood, or any of the larger 4-inch coarse screen items on this conveyor belt, which will dump into a dumpster at the other end and it'll be treated as hazardous waste. Okay, this is after the rake does its job and it dumps the coarse screen material onto this conveyor belt. It dumps it into a waste management dumpster and it's hauled away and treated properly and disposed of properly. We're going to go into the pump and blower part of the building. It's the same building but a different section. This is where the storm pumps are going to raise that water level I spoke of earlier up about 40 or 50 feet, and then the water is going to be gravity fed through the system from that point. It's very noisy in the next room. There's also air compressors, which we call blowers, in the next room. See, now if I spoke, I wouldn't even know if you would hear.
Okay, you try, but hold it like this.
Okay, just give me a nod. Right now, we're looking at the pump section of the pump and blower. This is bringing up the wastewater up to like 40 or 50 feet from where it was the last time you saw it. And now it's going to be gravity fed through the plant. At this particular time, we're handling 185 million gallons a day, which is a rather low flow. There's no rain event. That's low for us. And at this time, we have only 2 pumps on. And if you can pan to the right, the big white and silver machines over there are blowers. That's what's supplying our plant with compressed air for all our aeration tanks and all our controls. And there's 7 of them, and right now we have 3 of them on.
I'd say, get a lot of footage.
I'm saying it's raising about 40, 50 feet. That's about.
All right, we're in one of the 24-hour control rooms here at the Avila Water Reclamation Plant. Here our electrical operators and treatment and operating engineers monitor what's going on in the collection system around us and what's going on in the plant. The plant has what we call a distributed control system. It's a computer system that's used to control and monitor all the processes going on in the plant. And this is one of the central control rooms. There's always someone in this control room to respond to alarms and just monitor the condition of the facilities to make sure that our treatment process is going smoothly.
In this building, the sewage flows through the aerated channels at a slower velocity than it does in sewers. Because of the slower spiral flow, heavier inert materials such as cinders, sand, eggshells, and other smaller wastes settle out. This material is pumped out and disposed of in private landfills. At the end of the grit channels are fine screens that trap rags and other material that could clog small pumps and pipes.
Hey, we're coming in now to the grit building. Here we're going to remove all the sand, the rocks, the heavy solids that have accumulated in the wastewater. And also in this building we have now what's called the fine screen, which is going to be another process after grit removal, which is the other side of this building that we'll see. But the first thing that we're going to see is 6 tanks where we're going to be removing grit, and then it's, as you'll notice, that the water level is much higher now. The pumps that we saw earlier have raised that water level up now to where the entire treatment plant process from this point on is gravity fed. So I'll explain more on the inside.
So the first thing that Tom showed us was the core screen. And it's 3 inches openings, yes. And it collected all the debris, the heavy debris that doesn't go through the 3-inch core screen.
Correct.
And then the screen picks it up and then dumps into the dumpster, as we saw.
Correct.
Okay, and then it went into the pump and blower room, yes, where it pumps it up from the level of the as wastewater comes into the plant, which is 40 feet below. It brings up about 40 feet. And gravity flow is going to go into the grid room.
Correct.
Okay.
And from this point on, it'll be gravity fed. And the first part of the process will be grit removal, and that'll be in these tanks here. You ready? Okay, this is grit removal. This is grit tank 6. We have 6 tanks. This is number 6. This is where we're removing sand and dirt that it came in, well, you know, from the street and from the wastewater. As you notice, the water level is much higher than it was in the previous building. It'll all be gravity fed from this point. We're introducing air on one side of the grit tank to create a turbulence to get all the grit and all the sand and all the heavier items that came in to settle out. And we have a collector here. It's a piece of wood on a chain, for, you know, for lack of better description, that is going to move all the grit to the center of this particular tank, and then we're going to pump the grit out, and it's going to be disposed of properly after that process. And this right here is called grit removal. Okay, Kim, thank you. That's fine. This is the fine screen. This is the last screening process in the treatment process. I'm going to be turning on this particular rake for grit tank 6, and it's going to remove all the smaller items. The screen itself is a 3/4 inch screen. All the things that you think that you flush down the toilet that are gone forever usually end up here. As you can notice, the rake is going to go down below the water level, and then it'll come up with the screenings that it collected in that period of time. Once again, we're at low flow, so these are staggered. They're not on 24 hours. I mean, they're on 24 hours, but they only operate every 3 minutes or so because we're at low flow. I turned this one on manually just to give you an idea of what the tank actually, or what this particular fine screen does. Now, just like the core screen, it gets dumped onto a conveyor belt, and then it's disposed of properly. But if you notice, this is all smaller material, and this is the last screening process in this particular treatment process. If you want to get her raking this down too, that'll be fine. This is where the conveyor is going to dump the fine screens into a rather larger dumpster, because we have much more finer screens than coarse screens. And Tracy, one of the laborers here at the Water Reclamation, is raking it down, make sure we get as much in here as we possibly can.
Less than an inch. So this is really all the fine max.
Let's go to that tank over there. If you want, shoot down in there. Let me get some light in here. In the grit removal water tank that we saw just shortly ago, I was telling you removing the grit. Well, this is where this is the dumpster where the grit ends up. It's mostly sand, coal patch, rock debris, you know, bits and twigs, stuff that's primarily out of the storm sewer, more so than the waste end of the treatment process, but it has to be removed and disposed of properly. And this is what we call grit.
This is where the heavier decomposable solids are settled out of the raw sewage. These tanks hold the sewage in a relatively quiescent condition for a period of time to allow settling. Approximately 20% of the suspended solids, which are impurities in the sewage, and the oxygen requirements are removed here in the form of preliminary sludge. This sludge is then pumped into the concentration tanks. These tanks provide sludge storage at the Northside plant. Here are the sludges from the preliminary tanks, and waste-activated sludge from the final settling tanks are allowed to settle and compact under their own weight. The sludge percent solids increase slightly before it is pumped approximately 18 miles to the Stickney Water Reclamation Plant.
This is a primary tank 2. It's down for some routine maintenance. As you can see, it's empty. But this is how the operation works at this point. In the primary tanks, that metal apparatus turns very slowly clockwise, and those little paddles paddle everything to the center of that hole, which will be organic. In this particular tank, it will be organic sludge. And also in this tank, you'll see in an operational tank how the grease, fats, and oils rise to the top, and then they're skimmed off at the other side. So in the primary section of treatment, we're removing fats, grease, and oils from the top, and we're collecting our sludge and transferring it elsewhere. In these particular, we have 8 old tanks and 8 new tanks, and this is one of the older tanks that is under a little maintenance. Okay, this is an operational primary tank, and at the further end of the tank you see a silver metal flag moving slightly from the left to the right. That's telling me that the plow at the bottom of this tank is doing what it should. It's moving very slowly. It's collecting all the organic solids and shoveling them off to the center, and we're going to save a lot of the organic solids in our treatment process. And at the further end, the grease, fats, and oils will be skimmed off, and they will be removed and pumped into this building, and they will be disposed of properly. We have no use for the grease, fats, and oils in the treatment process at all. It's removed and disposed of.
And then the effluent, then the remainder of the effluent goes out into the aeration tanks.
Yes, the effluent here now will go out into our aeration tanks of all 16 tanks, and they'll be distributed equally to all 4 batteries of aeration. And then it'll start the biological process where we'll introduce air and raise the DO considerably. This morning when I came in and I did my test, the DO of this raw water was 0.4 milligrams per liter. The effluent was 5.9. That's how much we raised the DO.
And by DO, that's dissolved oxygen.
Dissolved oxygen, correct, Frank. That's as the meat and potatoes of treatment at this particular plant is dissolved oxygen.
Because as human beings, we need oxygen to live, to breathe.
That's correct.
And where the microorganism needs.
Yes, the microorganisms could not survive and dispose of the organic waste without being healthily fed with a good supply of oxygen, and we do that dissolved oxygen. And we keep the DOs as high as humanly possible. The higher the DO, the lower the ammonias, and the better the bugs live, breathe, and do what we want them to do.
All right, one little fact that I'd like to convey. We're at the end of the primary treatment process here, where we're settling out the heavy solids, and then the primary effluent is moving on to our secondary process. Up until about 1972, all that was required for treatment, the 72 was the Clean Water Act, actually 72 required primary treatment, and this would have been the end of the process in 72 when the Clean Water Act got enacted. We're going into a secondary process next, and the district's been doing that here at the O'Brien plant since 1928 when we're done, when we're actually treating even more than this, and we're going to an activated sludge process for a secondary treatment process to remove even more pollutants from the water.
In these long tanks, biological treatment takes place. A brown substance called return-activated sludge, which is composed of bacteria, uses the organic materials that remain in the sewage after preliminary refining for food. Thus, bacteria cleans the water by using some of the organic materials for energy to live on and by converting the remaining materials to additional cells. When converted, the previously unsettlable and dissolved organic material can be settled in the form of the flock. The portion used for energy is broken down mostly into water, carbon dioxide, and nitrate. The air from the blowers are needed because the bacteria requires oxygen for respiration. Bubbling the air mixture of sewage and sludge, called mixed liquor, provides this oxygen while agitating the mixture to keep the solids in suspension.
This is the aeration tank. This is aeration tank B. This is where the biological process takes place. This is where we're introducing air for the first time to help the organics to increase the DOs, to help the organics and the microorganisms remove the organic solids. And then when they're done removing the organic solids, they actually remove themselves to a certain extent. This process here, like I said before, we can in 4 hours accomplish what the fields and streams do naturally just by adding air, dissolved oxygen, to these tanks. We can do it in 4 hours, what takes fields and streams 4 to 5 weeks. And at this point, we're keeping everything very turbulent. We're making sure nothing sits still. We're adding as much air as possible. At low flow daylight today, it'll run its cycle for about 4.5 hours, and then it'll go to a primary tank, which will be not the primary, final tank, which will be the clarifiers, also known as, beyond those buildings, and that would be the last stage at this point of treatment. But right now, this is the aeration, and this is where we introduce air for the first time.
So here we're introducing dissolved oxygen to help
Yes.
the good microorganisms live.
Yes,
Okay.
very much so.
Okay, Gary. Tom.
You're up.
Oh yeah. So Tom, as you mentioned, they're injecting dissolved oxygen into the aeration tanks here so the microorganisms could live. And at this process, they're eating the bad bugs?
At this process, they're eating the organic solids, which is what we want them to do, and they're getting very, very energized with the dissolved oxygen, and they're actually, at some point, they could actually eat themselves.
I see. So actually what it is, the good bugs, microorganisms, are eating the bad bugs, the bad microorganisms here in the dissolved oxygen. And as I mentioned, we need air to breathe. And that's why, and then we have to generate more air in our body. That's why Tom, I think, ran this morning about 10 miles to improve his oxygen in his body. And so this is exactly as we see the in the pump and blower room. Are these the ones that are bringing in the air?
Yes, behind us, you have this big brown pipe. This is what's bringing air to all our aeration tanks. We have 4 batteries of aeration tanks. We actually have 64 aeration tanks, I believe. They're all controlled primarily with the air, and these big brown pipes is from the pump and blower building, bring all the air, and they're controlled by these valves, and they're also controlled by us in the TPO office on how much air we're going to add to the tanks. And that's what that brown pipe is for. But you may also notice a brown pipe that's below them on the ground. That pipe there is return sludge. When we're done with the clarifiers or the final tanks, we want to keep some of the good bugs and some of the good sludge, and we want to bring them back here because they're still healthy, they're still doing what we want them to do, and we don't want to send them all to waste. So we're gonna send them back to what we call the head of the plant through that particular brown pipe to the head of the aeration tank and just simply reuse them. And that would be called return sludge.
This is where the mixed liquor from the aeration tanks is held in a quiescent condition to allow settling of the flock. The sludge which settles here is pumped back to be mixed with the incoming sewage at the beginning of the aeration tanks. Part of the sludge from the final tanks, which is excess cellular material, is split off the return sludge and disposed of to the concentrated tanks. The overflow of the final tanks is the reclaimed water. The final effluent is discharged into the North Shore Channel, which flows into the Chicago River.
This is one of our clarifiers or final tanks. This is the last stage in our treatment process as it stands right now. That'll change with the UV disinfection in a year or so. But as you can tell from the center of this tank, you will notice the wastewater coming in is a little browner. That's coming from our aeration tanks. That's where the air was mixed with you know, all the organic solids, and it's created a very turbulent effect. What we're going to do now in this final tank is we're going to let everything die down a little bit. It's going to sit here for like 3 or 4 hours. It has the same plow mechanism as our primary tanks, but this is a final tank. It works fundamentally the same way. We're going to let the water and the sludge settle to the bottom. Now you can see it's coming in as murky brown, but as you can see also when it's leaving in a much clearer state. And this is what it looks like when it's leaving the final effluent, which is much clearer. And that's what we're going for. We're trying to clarify it. And what's going to happen at this particular plant in a year or so is after this final effluent stage, it's going to go to a UV disinfection building where it is going to be disinfected as well as purified. The water leaving our plant after that will actually be clearer and cleaner than the water in the river that it's going to. And hopefully that'll be by the end, you know, within the year. Yeah. Well, I was going to say, part of my job as a treatment plant operator is, are we live? Part of my job as a treatment plant operator is we run 24 hours here. We want to constantly monitor our samples that we send to our lab and to another lab for analysis. This is a sample station. This particular station here takes a final effluent for this particular battery, which is a battery. The sampler every once in a while will dump a certain measured amount of sample and we'll get a 24-hour composite. And then we will send this particular to another lab and have it analyzed for dissolved solids and various things that you look for in treatment. Also, this is refrigerated. Everything, every shift takes a 1/3 measure of mixed liquor, and at the end of the midnight shift, we do an analysis on this to see how our bugs are reacting and how healthy they are.
So is that
mixed liquor. This was the brown murky stuff that I showed you in the final tank. That was, we settled out, but we're going to save that because this is loaded with microorganisms from the morning shift, then the afternoon shift, and then the midnight shift. We're going to do a sample and see how healthy they are. And we'll do that 24 hours a day, every day, to make sure that our bugs are getting enough oxygen, they're healthy, and doing what they need to do.
So what you're doing here, Tom, is making sure that the people in Cook County, you're protecting their health and welfare. This is what the Northside plant is doing, protecting the health and welfare of the residents of Cook County.
Yes, sir, and we're making sure that our effluent is as clean as humanly possible and going to get cleaner with every improvement in treatment process. And this is a very efficient system, and most water treatment plants use a very similar system.
Tom, you have a very important job.
Yes, I do, and I really enjoy wastewater treatment. It's very interesting, and it's you know, it's a good occupation.
Yeah, and your position is a TPO, treatment
plant operator 1.
Treatment plant operator 1. Very important position here at the north side plant.
This is a final tank A1 that is being is shut down for service right now. It's very similar to the primary tanks, a little smaller plow, but it'll move the same way. The mixed liquor or the aeration water will come up through the center. It'll settle out. It'll sit in the primary tank, like I said earlier, for about 3 to 4 hours, and all the sludge, the return sludge, will be moved very, very slowly by that plow to the center hole where it will be reused. We actually only waste less than 10% of our return sludge. We just send it back to the aeration tank, energize it again with a little more dissolved oxygen, DO, and we keep the bugs and the microorganisms healthy, and they just keep on doing for us what they need to do, settle out the solids, and then we send clean water over the weirs.
One of the newest features in the Northside Water Treatment Plant is an ultraviolet disinfection system, which will be an added addition to the water treatment process. The disinfection system is slated to be completed by December 2015 and in full operation by February 2016. An ultraviolet disinfection system transfers electromagnetic energy from a mercury arc lamp to an organism's genetic material. When UV radiation penetrates the cell wall of an organism, it destroys the cell's ability to reproduce. UV disinfection is effective at eliminating most viruses, spores, and cysts. UV disinfection is a physical process rather than a chemical disinfectant, which eliminates the need to generate, handle, transport, or store toxic, hazardous, or corrosive chemicals. There is no residual effect that can be harmful to humans or aquatic life. UV disinfection is user-friendly for operators. UV disinfection has a shorter contact time when compared with other disinfectants. UV disinfection equipment requires less space than other methods. Disinfection is considered to be the primary mechanism for the inactivation or destruction of organisms to prevent the spread of waterborne diseases to downstream users and the environment. It is important that wastewater be adequately treated prior to disinfection in order for any disinfectant to be effective.
So we're looking out here at the site of the future UV disinfection facility for the O'Brien plant. The facility is going to be designed for the full capacity of 450 million gallons per day. What you see is just a big hole in the ground, but they've had to remove about 30 feet of soil to get to the level where they need to start construction at the base of the facility. So you see a lot of excavating going on, and you see stone going in. So hopefully in the next few months or next few weeks, we'll start to see the base of the foundation started, and then by December 2015, disinfection, the building should be complete, and we should be ready to disinfect our effluent going into the North Shore Channel for the 2016 disinfection or 2016 season.
And Arush, right now the effluent is treated for a secondary contact. Once they run the effluent through the ultraviolet light process, then it's going to be primary contact.
Yes, it'll be the effluent standard will be to the primary contact standards. So for fishable swimmables.
And so this is we're doing ultraviolet light here at the Northside plant, and you mentioned it'll be completed in 2015 in September.
December 2015 construction should be complete, and then the facility should be online and treating for in March 2016 for that season, for the waterway season.
And this is being discharged. This will be discharged into the North Shore Channel.
All right. What we're looking at now is the covered tanks in front of us. Here are the concentration tanks. What happens here is we're collecting the sludge from the primary sludge from our primary treatment process and our waste activated sludge. Those are the extra bugs and microorganisms we didn't need in the activated sludge process, and we're concentrating them and we ship them to Stickney via pipeline. We have a 16-inch pipeline that's roughly 16 miles long that goes to the Stickney Water Reclamation Plant from here, and we send them about 3 million gallons per day of sludge for processing in their digesters.
And the balance of the sludge you keep here to recycle to be used again in your processing here in your aeration tanks and in your preliminary tanks.
Yeah, the bulk of the sludge, most of it gets recycled from the activated sludge gets recycled back into the head of the aeration tank for treating more sewage, basically. So we recycle most of our sludge here. It's an ongoing, continuous process.
The main administration building houses the control center for the Northside plant. The control room is where plant operators and technicians monitor all the facilities at the Northside plant. There is at least 1 or 2 people inside the control room at all times to make sure that all the buildings and machines are functioning properly. The latest computers keep track of all the facilities to make sure they are all working properly. If a machine is damaged or malfunctioning, engineers can be notified and be sent to fix the problem.
Okay, we're in the control room over here at the O'Brien plant, and this is where we monitor the treatment process. Every stage of the treatment process is monitored from this room, as well as the room you saw earlier with the pumps, with the operating engineers. This is where the treatment plant operators do their monitoring, and it's manned 24 hours like the other room. On this particular screen here, we can go from screen to screen, but this particular one is monitoring the dissolved oxygen in our aeration tanks. Very important process. We have a screen set up for that. We're always monitoring, making sure we have the proper levels. And on this particular screen, I could change the returns. I mentioned earlier in the video about the return sludge and how much we can return. We can monitor that from just simply from clicking a mouse. I can change. Each individual tank is individually controlled, so we can control it. And there's 4 batteries with individual tanks. The screen over here to that left is monitoring the processed water building. This is how much that we're sending out, and the temperature and the DO. I mentioned DO many times. And dissolved oxygen. And our DO leaving the plant at this particular minute is 6.0, 6.1, which is very good DO for a treatment plant process. Considering this morning when I came in, the raw water was 0.3. So that's how much dissolved air we added for our bugs to be healthy, to do what they need to do in the treatment process of activated sludge. So our DOs are very healthy, got very good healthy bugs. And once again, this is where we monitor it 24/7. There's always someone in this room. And that's how we do it here at the O'Brien plant.
Thank you very much. My name is Commissioner Frank Avila. We just completed a tour of the Northside plant, but it's called now the Terrence O'Brien plant. And so any one that wants to come out and get a tour here at the Northside plant, they could contact our Public Relations Department, and we'll be happy to plan a tour for anyone that wants to tour this, the Northside plant. Please give us a call. Thank you.
We're going to talk a little bit now about one of the outlying stations here, the North Branch pumping station. You see one of the control screens for North Branch. North Branch is a pumping station that serves about 16 square miles in the city of Chicago. Basically, it's a pumping station that lifts flow from that area and puts it into an interceptor that comes to the north side, or comes to the O'Brien plant. It also is a combined sewer overflow, a CSO point for that area. So when the flow into the station exceeds what can be pumped out into the interceptor system, it pumps out it'll discharge a combined sewer overflow into the north branch of the Chicago River and provide relief there to prevent flooding in that 16 square miles of Chicago. The station is also, there's also part of our TARP system, the tunnel and reservoir plan. There are control structures, so before we do go to the river, we can divert flow there into the deep tunnel system and store that combined sewer overflow to prevent the discharge of pollution into the river for as much as the capacity is available in the tunnel. And then once that tunnel capacity is reached, then we there's no other choice to prevent flooding in the area other than to discharge the combined sewer overflow out into the river.
Also with TARP, during high rain event levels, we can detour a lot of our water from the north side O'Brien treatment plant to the TARP or the deep tunnel project, whatever you want to call it. TARP is a tunnel and a reservoir plan. That was TARP is just an acronym. But also, reason for TARP is if we were to get hit with an industrial waste hit of some kind that came into the plant and we noticed it on our screens, and we could detour that particular flow with that particular contaminant to TARP to be treated later, and it won't go into our system and it won't go into our river. That was one of the advantages of having a TARP system.
The Northside plant has a maximum treatment capacity of 450 million gallons per day. Flows in excess of this capacity, resulting from rainfall in the service area, are diverted into the TARP tunnel system for later treatment. Diversion of combined stormwater and wastewater into the waterways occurs during very large storms when the 1 billion gallon storage capacity of the TARP system is exceeded. The commissioners, engineers, workers, and residents of the Metropolitan Water Reclamation District of Greater Chicago continue their goal to keep our water supply healthy and clean.